Welcome to Eduauraa. This is Dipali, your chemistry teacher. Now students, it's time to solve few questions which are asked in the previous year examinations of JEE, NEET, etc. So let's start with the question answer session. A 10 milligram effervescent tablet containing sodium bicarbonate and oxalic acid releases 0.25 ml of carbon dioxide at 298.15 Kelvin and the pressure is 1 bar. If the molar volume of carbon dioxide is 25 liter, under such condition, what is the percentage of sodium bicarbonate in each tablet? Question was asked in JEE Mains 2019. Given information is molar mass of sodium bicarbonate is 84 gram per mole and the options given are option A 0.84, option B 33.6, option C 16.8 and option D 8.4. Now over here we have to find out the amount of sodium bicarbonate, that is NaHCO3, in given tablet. Now in the question if I check, then sodium carbonate is reacting with oxalic acid. So my reaction will be 2 moles of NaHCO3 plus H2C2O4, where H2C2O4 is oxalic acid, forming Na2C2O4 and release of carbon dioxide and water. Over here we have to find out the moles of CO2 and we have to relate it with NaHCO3. So moles of CO2 released are equal to 0.25 divided by 25 into 10 raised to 3. So the moles of CO2 are equal to 10 raised to minus 5. Now if I check or compare the moles of CO2 and NaHCO3 in balanced reaction, then both are same. Therefore, moles of CO2 is equal to moles of NaHCO3, which are equal to 10 raised to minus 5. Moles we know, we can find out the mass by using number of mole is equal to weight in gram upon molar mass. So multiplying the moles with molar mass, the amount of NaHCO3 will be equal to 0.84 into 10 raised to minus 3 grams, which is equal to 0.84 milligrams. Now if we are to find out the percentage weight, then percentage by weight is equal to given information multiplied by 100. So answer is equal to 8.4%. So 8.4% of sodium bicarbonate is present in given tablet. Let's see the next question, and the question is a sample of NaClO3 is converted by heat to NaCl, that is sodium chloride, with loss of 0.16 gram of oxygen. The residue is dissolved in water and precipitated as silver chloride, that is AgCl. Mass of AgCl in grams obtained will be. Given information is molar mass of silver chloride, that is AgCl, is 143.5 gram per mole. The options are option A 0.35 gram, option B 0.54, option C 0.41 and the last option is 0.48. This question was asked in JEE Mains 2018. Now over here we have to find out the mass of AgCl, and this AgCl is obtained when NaClO3 is converted into NaCl by using oxygen and the given component dissolved in the water. When we consider the number of moles of oxygen, then number of moles of oxygen in 0.16 gram of oxygen molecule. So this number of moles is equal to weight upon molar mass. So 0.16 divided by 32, where 32 is molar mass of oxygen. Answer is coming out to be 0.005 moles. Now we know the reaction that NaClO3 is converting into NaCl. So On heating, it will produce NaCl and it will release oxygen gas. If I balance the given reaction, then 2 moles of NaClO3 will form 2 moles of NaCl and 3 moles of oxygen gas. Over here, the stoichiometric ratio is 2:2:3. Now students, 3 moles of oxygen are released when 2 moles of NaCl is formed and 2 moles of NaClO3 is consumed. So the mass of AgCl, if I had to find out, then first we will consider molar mass of AgCl, which is equal to 143.5. Now 0.005 gram of O2 if I consider, then this is the amount which is utilized or the released when NaClO3 is forming NaCl. Now students, 0.005 moles of oxygen will get precipitated out, then my answer is 0.005 into 2/3 moles of AgCl. So over here we have compared the oxygen and AgCl stoichiometric coefficients. And if I find out the correct answer, then answer is 0.0033 moles of AgCl, which means 0.005 moles of oxygen will produce this much amount of AgCl. Now the mass of AgCl, if we are to find out, moles we already know. If we will consider molar mass, it is already given in the question that it is equal to 143.5. So number of mole into molar mass, we will get mass of AgCl, which is equal to 0.48 grams. So correct answer is option D, that is 0.48 gram of AgCl we will get when oxygen is combined with the other reactants. Let's see next question. Your next question is a solution of two components containing N1 moles of first component and N2 moles of second component is prepared. M1 and M2 are the molecular weight of the component 1 and 2 respectively. If D is the density of the solution in gram per ml and C2 is the molarity and X2 is the mole fraction of the second component, then C2 can be expressed as, you have the 4 options and your first option is option A, C2 is equal to 1000 X2 divided by M1 plus X2 M2 minus M1. Option B, C2 is equal to dx2 divided by M2 plus X2 M2 minus M1. Option C, C2 is equal to 1000 multiplied by dx2 divided by M1 plus X2 M2 minus M1. And the last option is C2 is equal to X1D divided by M2 plus X2 M2 minus M1. Over here, C2 is the concentration of the second component and we have to find out the value of the second component concentration in terms of density, molar mass and the mole fraction. Let's start with the solution. In the question, it is given that N1 and N2 are the number of moles of first and second component. M1 and M2 are the molar mass of first and second component respectively. So students, by using the number of mole, we can find out the mass of that component by using number of mole is equal to weight in gram upon molar mass. So weight in gram is equal to number of mole multiplied by molar mass. Therefore, mass of the first component is equal to N1 into M1 and mass of second component is equal to N2 into M2. So if I consider total mass of the solution, which is equal to N1 M1 plus N2 M2. Now students, the mole fraction of the second component will be equal to number of mole of second component divided by total number of mole. So it will be N2 upon N1 plus N2. Now if I consider N1, then N1 will be equal to N2 multiplied by 1 minus x2 divided by x2. This equation we have followed by using the equation 1. Now students, we know that mass of the solution is equal to N1 M1 plus N2 M2. In this equation, if we will substitute the equation 2, then my formula will be N2 M1 in bracket 1 minus x2 divided by x2. So we have substituted value of N1 plus N2 M2. If I rearrange the term, then mass of the solution is equal to N2 upon x2 multiplied with M2 x2 minus x2 M1 plus M2. So we have to find out the volume of the solution. Then in this question we have the mass of the solution. So density is equal to mass upon volume. Therefore volume is equal to mass upon density. Mass we already found out in equation 3. So we will substitute the mass from equation 3, which is this. In the denominator we will write down density, and density is given in ml, so we will multiply with the 1000. So students, to find out the concentration, we will take number of moles of the second component, which is equal to N2, divided by volume of solution, which is nothing but equation number 4. So after rearranging the term, we will get this equation, and this equation is same as option C. So correct answer is option C. Let's see the next question, and the question is average molar mass of chlorine is 35.5 gram mole inverse. The ratio of chlorine 35 to chlorine 37 in naturally occurring chlorine is close to. So we have to find out the ratio of isotopes of chlorine, and the ratio is option A 4:1, option B 3:1, option C 2:1, and option D 1:1. Students, this question was asked in JEE Mains 2020. In this question, they are talking about the molar mass of the chlorine is 35.5, which is the average molar mass. And to find out the ratio of chlorine 35 to chlorine 37, we should know what is the actual number of mole and what is the abundance. So mole ratio is equal to X for chlorine 35. So let's consider X mole of chlorine 35 is present. If I consider total 1 mole, out of which X is chlorine 35, so 1 minus X will be chlorine 37. If I consider molar mass, which is average, which is equal to abundance of the first component multiplied by its molar mass, abundance of second component multiplied by its molar mass, and add both of the component. If I use this concept, then average molar mass is equal to 35 multiplied by X plus 37 multiplied by 1 minus X. And we know that average molar mass is already given in question, which is 35.5. So students, if I find out the value of X, then value of X is equal to 3/4. So students, if I check the ratio of chlorine 35 to chlorine 37, ratio is 3/4 divided by 1/4, because out of 4 parts, 3 parts are there for chlorine 35. So remaining 1 part will be for chlorine 37. Therefore it is 3/4 divided by 1/4, and the answer will be equal to 3:1. So 3:1 is there in which option, that we will see. So correct option for given question is option B, that is 3:1. Let's see the next question, and your question is, among the following statement, that which was not proposed by Dalton was. This question was asked in JEE Mains 2020. The options given are option A, chemical reactions involve recognition of atoms. These are neither created nor destroyed in chemical reaction. Option B, all atoms of a given element have identical properties, including identical mass. The atom of different element are different in their mass. Option C, when gases combine or reproduce in any chemical reaction, they do so in simple ratio by volume, provided all gases are at same temperature and pressure. And the last option is matter consists of indivisible atoms. Now, in the question they have asked that which of the following is not proposed by Dalton. When we consider the Dalton, then according to Dalton, the chemical reaction involves recognition of atoms. These are neither created nor destroyed in chemical reaction. This statement is given by Dalton. If I consider option A, B, C, D, then except option C, that is, when gases combine and reproduce in chemical reaction, they do so in simple volume ratio, provided, which means condition, is same temperature and same pressure. This statement is not given by Dalton. So, option A, B and D are given by the Dalton except option C. So students, this is Dipali Chitroda signing off for the today. Stay connected with Eduauraa. Thank you.